Hey guys, it's Blake, and I am actually happy for this episode because I increased my YouTube limit, so now I can upload videos that are actually a lot longer than 15 minutes. So you're going to be seeing that now, maybe even like some hour-long episodes, because as we get into these more complicated topics, there's going to be times where I need more than 15 minutes if I don't want to separate it into parts. And I really, really do not want to separate things into parts because, oh, sorry, I just burped a little bit there. But, for one, it's irritating for the person who's, watching the videos, because you have to search through parts, and you can't remember, if you need to review something, you can't remember what part it's in that you need to review it, and it gets way too messy that way, and personally, I hate it when people separate things into parts. I'd prefer to watch all in one sitting. Or whatever. So just ignore all this other stuff for now. The topic of today is going to be arrays, and a little introduction on allocated memory. Now, I've previously recorded this like 4 times, so you are going to see a buttload of stuff on this. Don't worry about any of that right now. I'm going to explain all of that in due time. So, I also have an example set up in here, where it outputs 10, 11, and 12. But don't worry about that quite yet, either. So to start off, I'm going to tell you that we've already reviewed arrays. I told you about how you could use them, if you had like a character and, you know what, let me just do this real quick. I'm just gonna cut all that real quick, and I'm gonna show you exactly what we did. Character X25. Actually, see out. Hello, what's your name? End line. And we could actually say X 25 oh, that's what I did wrong. Oops. And I could say hello could say something like that. Oops. Did not mean to do that. Hello, what's your name? Hello, B. Stacker on variable X was corrupted. Should I be doing this in release? I believe that I should be. That's strange. It says the stack around it was corrupted. Would it have something to do with that? I believe it was. Hello, number sign. It's very interesting. Okay, so I'm pretty sure it had to be that. Maybe it was this one that didn't need to have it. Nope, that didn't help either. Anyways, it was something like that. I can't remember exactly what I did, and I'm too lazy to figure it out now. So, yeah. You can review that. I think it was like my first or second video that I went over that where I showed you how to do that. And yeah. So, let's move into the next part of arrays here. I'm gonna be showing you how to use them with integers. Okay, so the first thing that you need to know is about allocated memory. Your computer, it looks at to see how many integers you have. And it does this, how can I put this? You don't forget what I said about that. That isn't important. I'm just going to go over what it is in general, not a specific example. Which actually I will just do a specific example, because that's probably the best way to show you guys. So let's say I had an integer. Whenever it sees an integer, it knows that it's 4 bytes of memory. A byte, in case you guys don't know, is an amount of memory. So, your integer, long category for ints. Let's go 72. And so let's say I declared an integer. It would say, okay, how many integers are there? Well, let's say we only had 5 integers declared in our program. Easy enough, right? But let's say that we had int more. Wait, what am I talking about? Oh, bytes. Stupid Microsoft Paint. Bytes. Byte. There we go. An integer is 4 bytes. Let me change this to something like 30 so I can actually do this. Okay. Int equals 4 bytes of memory. So if we have int and there's 5 of them, it's going to equal 20 bytes. So computer allocates 20 bytes. Okay. So, for every integer, it's given 4 bytes. So, this is a good example of using arrays in general. We have 5 arrays here, right? Because it doesn't start at 1. I believe I have that. This one. They don't start at 1, they start at 0. So if I need to declare 5, we go 0, 1, 2, 3, 4. But that's technically 5. See, 1, 2, 3, 4, 5. That's 5 integers. So if I were to declare 5, that would actually be 6. There's our 6th, which looks like a B, but just know that's a 6. So it's kind of tricky because it starts from 0. But it's easy enough. Nope, it's not what I was looking for. So we have 20 bytes because it just multiplies it by 5, because that's how many, or multiplies that by 4. So 5 times 4 is 20. So the computer allocates that memory. Allocate means it makes space for it in like a memory disk kind of thing. That's still a very sloppy explanation of it, so let me go more in depth on how your computer accesses memory and stores it. So your computer has a hard drive, right? Or like an internal disk or something that it stores memory on. We're going to call that our hard drive. Hard drive, even though there's no space there. And your hard drive has places of storing memory. And it stores memory on it in a bunch of different ways. So, one of the ways that it stores it is basically by making spaces for each and every little variable that you create. So let's say I have x and its array value is 10. Okay, well your computer says, okay, we need to make room for 10 10 different variables. So what it does is your hard drive accesses your GPU, which is another part of your computer, and that is where memory is stored. Well, some of it. Memory is stored in a bunch of different places, but this is one of those places. So the first thing that it does is it creates a space for x0, because it starts at whatever it is. It starts at 0 and it goes up to 10. And the next thing that it does is it makes its own little space for x1, and then eventually x2. I know that's very sloppy, but that's just because it's a quick diagram. But this is your GPU, and your hard drive is going to store that in here, which is a part of your hard drive. Okay, so then what it does is it gives each of these an address, like in memory. So this would be like 1, 2, 3, 4, 5, and so on. That's very sloppy once again because I can't write with this stupid pencil thing. Don't have steady enough hand with my mouse to do it. Maybe there's some mystifying secret that I'm not getting there. But whatever. So that's basically how your computer stores and allocates memory. And you're probably confused how this comes into play here. Well, when you are using arrays, these things, your computer needs to know at compile time how much memory you need for your program to run properly. So what it does is it does all this stuff over here, and it stores those variables. So that way it can figure out how much memory it's going to need. So in this case, where we have the number 10 in there, which is actually 11, because remember it starts at 0, it would multiply times 4. So it would declare 44 bytes of memory. Sorry about that, I had to run and talk to my parents real quick, but I'm back. But anyways, what was I saying? Yes, it declares 44 bytes of memory. So our total is 44 bytes that we have. Voila. So, if we tried to use more memory than that, like let's say we tried to output x11 equals like 15 or something, we would get an error saying like, for one, that x11 is undefined, but let's say that our compiler ignored that error, and it actually outputted this. It's very hard to explain, because it's a console project. I will get more into what that does if you access memory that isn't there later in videos, when we actually start using this in the GUI, the graphical user interface. Because for one, you can't access memory that isn't there in a console project, so it's not even worth talking about, really, but I'm going to do it anyways. But what it does is it like flashes, maybe whatever you're drawing to the screen will like flash and then disappear or something, or it'll just like blink, like it'll be there and it'll disappear, and a second later it'll be there again. And it makes it really hard to have a game like that because it looks really glitchy. And that's the best way I can explain it right now. You'll see what I mean later, in about 30 minutes or so on in the video, or however long it takes. I'm guessing it'll be about that long though. But essentially, that's the majority of what happens usually. Sometimes every little thing on your screen just disappears completely and you're left with like a blank, like black screen. Not your actual computer screen, but like the game window where the game is. that'll just like turn black. You can still close it and stuff and go back to your regular screen, so it's not like it crashes your computer or anything, but it will screw up the game and you'll probably encounter errors with it. I'm not really sure what it would do in a console project, but like I said, it probably won't let us do that because it's going to say X11 is undefined. So your computer allocates that memory and gives it an address, and then it takes that address, and whenever that variable is used, it looks at this address and says, okay, we're using X. Oh, crap. Let's say that was like X10. Okay, let's say that X10 is equal to 10. So what it does, it's going to look at X10 in memory, and it's going to see where it's located in memory. It's going to go, okay, where's this located? This is located at 0042. Let's say that was where it was located in the memory. Like, that was its literal address in the memory. Okay, well, it is going to say, okay, now what does 0042 equal? Oh, it equals X, or it equals 10. So what it does is it outputs this to the screen. And so let's say that we had, I need to clear some of this up, or at least make the screen bigger so I can put more down here. Okay, so let's say that we were trying to output something like X11. So X11 equals 11. Okay, well, your computer would try to go to that address in memory. It's going to go, what did I do? X11. Where is its address at? Okay, well, it isn't defined. So you're probably going to get something like a bunch of numbers, or letters and then numbers or something, because that's a garbage number. It doesn't know where it's located, so it kind of outputs like a random value for its address, and then it's going to say, okay, where is FGBDG 21312? What's its value? And it's also going to be a garbage value, because remember, that value doesn't exist. So you may get something like that, because that value does not exist in your program. So if we tried to draw this pixel on a screen, it would screw it up, because there's no screen that's that big. At least any screen that I'm aware. There's no screen that has 347,000 pixels on a screen. The screen that we use only has 800 wide, so our program would actually crash if we tried to draw this, because it will not draw that pixel on the screen. So if we tried to do that, our program wouldn't even run. And that is one of the dangers of using memory that your computer has not allocated to you. So I hope I've talked enough about memory now, because that bores me even. So now that we have allocated memory out of the picture, let's go ahead and cross it out. So now I know I don't have to talk about it. That too, we don't need to talk about bytes anymore. And that we talked about. Alright, now the next part is going to be using the variables correctly. So we have right here a maximum value of 4. We have X, and then we've declared it to the 4th. So we have a maximum value of 5. Sorry if I said 4, but there's 5. So we have a maximum value of 5 X variables we can use. And we are currently accessing the very first one. So once again, it's going to look at this value, and it is going to look at its address in memory. Make that bigger. Whoop. And it's going to say, okay, where is that located? I'll make it a little longer this time, so that way I have more room. Yeah, that's fine. So it's going to find the X0. Okay. X0. And it's going to look at it where it is in memory. Okay. Where is it located in memory? Okay, well, I don't really know. So let's just make up something. So 0042, because I already did that. Alright, cool. Now it's going to look at 0042. Now, what are we storing in that? We are storing the value of 5. So it would look at that, and it would say, okay, what are we storing in there? 5. And then the output is going to be 5, obviously, which I already have up there too. So, vice versa. Let's say we were calling that function. And where's my mouse? Oh, there it is. Okay. So let's say we did console output x0. Well, what it does, once again, is it looks at x0. What's its address in memory? 0042. What do we have that equal to? 5. So output 5. So it kind of works both ways. When you're using it, it does that whole process again. And that's how it finds its variables. So if we had like x1, it would declare a new spot in memory. It wouldn't erase that old one. It would actually create its own little spot for x1. That way x1 and x0 do not get confused at all. And it would give it the next open slot in memory, which in this case is 0043. Now we can assign it a completely different value here. Let's be original. 6. So its output when we use it is going to be 6. And these two variables, even though they are x, they can exist with each other basically forever in this state, because they're not going to get confused. Because I know it is confusing, but if you still don't get it, take a look at the memory. They're in completely different slots. 0042, 0043. They're not being confused. And that's one way why a compiler never gets confused when you use arrays, is because it looks at its address in memory, and it never just happens to get confused. It's always constantly aware of what's going on. It's always independent here. So I'm just going to run to the bathroom real quick, and I will be back in a second. And I am back now. Can't quite remember what I was talking about. I wonder what I was talking about. Whoa, wrong button. Okay, there we go. I believe I was talking about how they don't get confused in memory, because your compiler always knows that they're independent of each other. Yeah, I believe that's where I left off. Okay. So, your compiler will never ever get them confused, because it doesn't actually look at the variables. It looks at the variable and then looks at where it's located in memory, and then it uses this address basically to separate them. It does that for all variables, but a good example is arrays, to also demonstrate that. So, and another good example is because I could have like x and y, and there could be a maximum of 4 or 5 values for them, and I could set this one to like 200, and I could draw an enemy there, or I could set this one to these ones to 300, 300, and they can be completely independent of each other, be using the same variables, but be two different enemies. That does make it kind of tricky to do, like collision, but I'll talk about that in a second. So, about 25 minutes in the video, not bad. I've got a little program here that is using a define statement, which is slightly more difficult, and it's okay to use. How should I put this? It's like a way of telling your compiler that we're going to be using a special kind of variable in here. Because remember how I talked about allocated memory and how you can never have a variable in there? Well, this is the only exception. And see, it runs just fine. To prove it to you. Is that screen going to stay big? Aw, no. Okay. Well, anyways, let's get rid of that. We're not even using that. So let's say that I didn't know how much space I was going to need, and I could have like int x, y, z. I could have all the letters of the alphabet, and I could have them all set to like 5. Because that would be like how many enemies I wanted to draw out of the screen or something. Wouldn't that just be a bitch if I needed to go through and change every single one of those to like 6 if I wanted to draw one more enemy to the screen, and all those variables were pertaining to the enemy itself? That would be a big hassle. And I would probably just say, you know what, screw it, I'm not even going to draw that many enemies, and I'll just leave it at this. And that would make for a crappy program, because it wouldn't be challenging. So they have a way of getting around that, and that way is the define statement. You can define this special variable, and if we try to use a regular variable in here like y, it would say that it's not a constant. Okay, now the reason it says it's not a constant is because, like I said, variables can change over time, and they will change throughout your program, whether you know that or not. They slightly change. So it'll tell you that it's not a constant. So we can use number define nx7, and that way it looks at it as a constant. I don't know if I can do like const int y equals 5. Maybe to let me do that. And maybe I could use like y in there or something like that. I'm going to try that real quick, because that might actually work now that I think of it. Y. Yeah, so that does work. I believe that works as well. Yeah, that works. Cool. But const means constant. So the only way you can use a variable in there is if it's a constant. But typically you're not going to see that, because for one, it's just not good programming practice. In your array, if you're going to have a constant, you should not use that. You should use a define, and then use whatever you define it to. Nx, meaning number of x. Which I guess I should lead into a little subtopic here, is Hungarian notation. Because I've been doing this a lot. I've been meaning to talk about it, but I just haven't. So, it's Hungarian notation, which sounds complicated, but trust me, it's not. Where's my little arrow pointing to the right? Now that is like nx. It means number of x. Oh god, I can't think of any examples. Let me go to this website real quick, because it has plenty of examples on it. Hungarian notation, right there. Okay, so like this, n value, it shows that it's an integer. Or for example, we have this double right here, which is a type of like int. It means it can hold a double value, which means a large value. For example, if I did like 187,425,116,000,000 15 or 150,112, our compiler would say, holy crap, that's way too big of a value for an integer to hold, but maybe a double could hold it. But as you see, its name is width, but it's dwidth. The d shows that it's a double value. And this means number of x, but it shows that n is an integer, or it shows that x is an integer. So a more proper value, or name, because typically when you're using Hungarian notation, you do n, lowercase, whatever it is, and then capital, whatever you're going to call it. Or if it was a float, it would be like fx, dx, lx for long x, sx for short x. Basically, that's the point. But for this, it would technically be n capital X. And just to let you know, the rest of it doesn't have to be capitalized, so it's not like nx blah blah blah. It could be nx blah blah blah, lowercase. And that's how Hungarian notation is. I just thought I should cover that real quick. because you might be confused why I called it that, but typically you're going to see that a lot in programming. So anyways, we use a define function in there, because that's just good programming practice. Yes, it's always good to know that you can use a constant variable in there too, in the rare case, but for now, just stick with this. Yeah. So we have x0 set to 10, x1 set to 11, x2 set to 12. So we can set these variables differently, and then we can output them all. And it's just gonna say 10, 11, and 12. So yeah. And just, you guys might be looking at this and wondering why I don't have to put number include std afx. Well, it's because when you make a new file, click or when you're making a new console project, for example, I'll do new project, click Win32 console, name it. I'm just gonna make a junk name real quick, and you're gonna see this thing. Click next, click empty project and deselect precompiled header, click finish, and then you're gonna see something like this where there's absolutely no files in here. Right click add on your source files .cpp file, and you're all good to go. Oh crap, I just closed off my IDE, but who cares. Yeah, you can add a file like that, and that way you don't have to put it in there. So I believe that I've covered all of this. Now I'm going to talk to you about what happens when you use memory that you haven't allocated. Wait, did I already talk about that? I believe that I might have, but yeah, I can't remember if I did or not, so I'm just going to go ahead and talk about it again. Sorry if it's a repeat. But we have it only declared up to the 4th value, or technically 5 spaces in memory. Let's say we tried to use the 5th. That is technically considered the 6th value in memory, and since that doesn't exist, if we were drawing something to the screen, it would give us a junk value, and it would completely crash our program. Or they might like flicker or something, like my mouse is doing right now for some reason, which is really weird. It's probably because low performance while I'm recording. Yeah, stupid Camtasia recorder. Why are you so slow? So that's pretty much everything about arrays, including the define, and why you should use it over a constant int and stuff. Or a static int. Have I talked about static ints? I don't believe that I have. A static is pretty much the same thing as a constant. It doesn't change either. So if I were to declare like static int x, it would expect x to stay the same and it would never change. So you may be able to use that too. I don't really know, but you're more than welcome to try it. So, now that we've done all of this, and we've covered the complete topic of arrays, I guess I'll go ahead and save. Yeah, what if I need to do this again? Arrays.png. Save. Arrays2.png. Alrighty. So, let me just pause the video while I extract the files real quick, so that way you guys aren't waiting forever. And I'm back. It's just the regular framework, not the updated, so you don't have to extract that. We're just going to be using the regular framework, because for one, I don't really use much mouse input in my games. Even though I know how, it's just pointless to me to even do. And I'm going to show you guys how to use arrays in this, which is actually pretty simple in its own little way. So let's make some variables. Int x ne, and that's going to stand for number of enemies. But what do we have to do? Go up to the top here underneath the keyboard thing, do number, define ne, and let's set that to 5. And this is going to be your graphical proof that it works. Int y ne. Okay. Now, the first thing that I need to do is make sure that they are not located at the same point ever. So let's just do a number include std lib.h, and also do a number include time.h. What the hell did I do there? Time, oh, lowercase t, sorry, .h. Cannot type today. So first of all, when you're using an array, you can't go in here and do like x, ne, and then assign it a value, because it just won't let you do that up there in this little initialize thing. So if we wanted to give like it a specific value, we'd actually have to like go inside of our game and do like x, ne equals whatever. So just to let you know, you can't initialize it up there. But we're going to be doing something different. We're going to be using this constructor box. A constructor box is, as you notice, it's like a little box that doesn't have a little line on top of it telling it what it is. There's some cases where they can be used, like for example, right there would not be one of them, because it's going to say expected a declaration of what though. So it's not applicable to be used right there. Up here is a case where it would be used, but as you see, it does have that line up there. So you know, it's just kind of tricky. I'm not even going to explain how and why and when they're used, but just know that you have to put this in there every single time. So we want to do srand. Why is it telling me? Alright, never mind. Just do unsigned int time null. Now I'm glad that I've recently talked about the define function, because if you go over null, it says number defined in null 0. So we can actually put 0 in there too, and it would run just fine. But here's something kind of cool, is it doesn't have to be null. We can take other stuff and define them, like pizza, and set that to 0, and I could actually use pizza in here and it will work just fine. See, number defined pizza 0, and it's not giving me an error. And we want to set our x and y values. So x, ne, which means wherever there's an x value, set it to a random value. But we want to be able to draw it in the screen. What if its value is greater than what's on the screen, or less? Because I think the values that it goes from is like negative 3 million something to like positive 3 million something when you're using a random function. So in reality, it's actually very weird how you do it. You would actually have to kind of do a mathematical formula, a very easy one, but we do a random number from 0 to 800, but we have to subtract how many pixels wide our object we're going to be drawing is. I'm going to be drawing just 1 pixel to show you guys that it works, because I'm too lazy to draw anything else. So -1. And then we also have to set n or x at, or sorry, y at ne to the same thing basically. Why is that? Our expression must have a pointer to function type. What the hell is it telling me that for? It's not that. Oh! Random number. No, it should just be that. Did I include the right library? Yes, I did. I'm just going to go ahead and get rid of that. And go ahead and use null. Is that what it's complaining about? Is that why you're so moody today? I'm going to pause the video and check that out real quick. Oh, silly me, I forgot my modulus operator, which I already talked about. The percent symbol. Such a rookie mistake. Where's my brain today? Now we want to do the same thing, except we want to do 600, because the y-coordinate is 600 minus 1. Do you guys all got that? You know why we did that? I hope you do, because that is going to be the width and height of our project. Or whatever we're drawing. So, gfx.drop put pixel at x, any, comma, y, any, and 255, comma, 0, comma, 0. Just because I can. Now, let me check. Is anything going to go wrong here? No, everything should be good. Alright, now, if you look at this, there's only one pixel there. And a buffer over corrupted for internal state, press break. How to debug overrun issues. Something tells me debugger was present. That's really weird. Don't know what kind of error this is, but I'm going to check it out real quick. Why is it only displaying 1? Stack around the variable the game was corrupted. That is strange. I don't even know how to fix that error. GS report debugger was present equals is debugger present if defined define SYRCT end if defined. Make sure any filter is already in place deleted. Huh. Stack overrun. Okay, well I think what's happening is my computer is running low on memory. Because I'm recording. So it's giving me that error because it can't define 10 of those. So you can just go ahead and run this code for yourself. And it definitely should have worked just fine for you. I'm really not sure why it's not working for me, but that's my best guess. But I have faith that it works. And if it doesn't, you guys can message me in the comment section below, or you can email me. I'm going to put my email in the description. And any games that you guys are working on or something, feel more than happy to message me those games. Just extract them to a downloadable zip file and email me that zip file. If you guys do not know how to do that, then I'm sorry, you don't know how to use Google either, apparently. But I believe that I've covered the topic of arrays very well, because they are a complicated topic, but we're going to be using them so often. So rewatch this video as many times as you need until you pretty much have a great understanding of them. Or use that website, learncpp.com. That I reference so much because that's where I learned from it initially. So I'm gonna reference back to it a lot, and we're probably gonna be looking at examples from there somewhat. Maybe I want to show you guys some examples when we do pointers, which is gonna be our next video, which is an extremely complicated topic. Well, not really complicated, but it's definitely got its issues. When you are looking at pointers next video with me, I'm going to explain their practical uses, but I'm just going to let you guys know that pointers are a complicated topic, as in you don't know how to use them in a game-wise, and you're going to need to know them when you get into like really advanced programming, so that way you can render better graphics and stuff, and make your program go faster. But beginner programmers have a hard time trying to figure out how to use them, and then advanced programmers have a hard time trying to use them while still keeping their program simple to read, which often you can't when you're using pointers. So thanks for watching, guys. Comment, rate, subscribe.